How are you, everybody who is watching this video? My name is Olenjolai Moko Tayai Losingo. Simply call me Olenjolai. I'm from the United Republic of Tanzania. Simply call it Tanzania, eastern of the African continent. You are warmly welcome to Tanzania. Today, I'm very happy to be with you, and before even I go into too much details of what I've prepared and God has prepared for you in me, I would like to welcome you into Tanzania Online Advanced Secondary School in square bracket Olenjolaim. So Olenjolaim, this is my name, just you have to call me Olenjolaim. So this is our online school. But again, we have simultaneously, I would like to welcome you into our YouTube channel. That's one of our YouTube channels. We have 6 YouTube channels, but this is one of them that's called the Tanzania Online A-Level Secondary School in square bracket Olenjolaim. Well, so this is a kind of fantastic modern secondary school, advanced secondary school, and real that whether you are a national or international student, whether you're a national or international parents or guardians, you are really welcome to enjoy the beautiful advanced education. So this program, I'll be focusing, I'll be using the syllabus of United Republic of Tanzania. However, that I'll be, mathematics is universal. And because mathematics is universal, so what am I going to teach? The contents are also universal. So mathematics itself is universal, and the contents also are universal. So whether you are a national or international students, get prepared. We are going to do great things in advanced education, these online advanced educations. You have been experiencing so many problems on learning, on mastering advanced mathematics, on mastering advanced chemistry, on mastering advanced physics, on mastering basic applied mathematics. You have been wandering around, you have been troubled, you have been thinking, you have been confused, you have been stressed out. So now, tell in your mind that the solutions is here. So where the solution is? In Tanzania Online Advanced Secondary School. So here we have a vision. We have a vision because the word of God says that if there's no visions, people perish. If I don't have visions, I'm going to perish. And even yourself as a student on your side, if you don't know the visions for Tanzania Online Advanced Secondary School in square bracket Olenjolaim, you won't adapt and extract all the piece of information which are very important for you. So these are the visions that God has given me. God has asked me to prepare. Some of the students will be ready to use their mind, the intelligence, the understanding, right? To take the classroom instruction, advanced educations, combined with the knowledge from the Word of God in order to solve real life problems. So you see that these visions are 3 parts. First of all, you should know and master well the classroom instructions, their formal educations. Whether you're a private student, you're a school candidate students, or you're private candidates, don't get confused. This program is for you. This program is for any private candidate student and also for any school candidate students. This programs also is to add some materials, a reference material for the advanced teachers, is a reference material for the mathematicians, is a reference material even for people who want to use to solve problems in mathematics. So mathematics, yes, and even in science, and even in some other fields. So our main objective here, so remember the visions are 3 parts. Learn the classroom instructions, and then combine with the Word of God that you have to think outside the bracket of the information that you have. Should have a knowledge of Word of God. Combining these 2 great knowledge, and then solve a real life problems at the same part of our vision. So our main goal, to see our continuing advanced students, and even our graduate students, we call them in advanced education, solving real life problems, even a small scale problem. Even the problems of fixing a light bulb at your home, in your parents' homes, in your place. Even if you are solving a problems of maybe the tap of your parents is not working, and then you want to fix up that problem. So we can have small scale real life problems, medium scale real life problems, large scale medium problems. What am I going to do? First of all, I will change the way you're thinking. Your way of thinking, because I think differently, and I'm working differently, and I'm judging differently, and I'm getting different results. right? So that's our main objectives. However, we have we have so many specific objectives in this platform. One of them, we have to teach, we will make every students to love advanced education, to love advanced mathematics, to love advanced physics, advanced chemistry. That's one of our specific objective. Our second objective would like to help you to pass all your midterm testing, all your terminal exams in advanced educations, all your advanced, all your we call it all your annual exams, right? In Form 5 and also in Form 6, or in class 18 and also in class 13 and class 14. If you're a pre-Form 5 student, my dear students, I want to tell you, you are in a very right position. You're in a very right place where that you can learn and get prepared about every piece of information you have to know in advance, before even when you are advanced education students. So stay focused, stay tuned. We want serious students, be serious, and then get ready to change your way of thinking and get ready to lead your area of gifting, right? Because that's what you are going to do here. So before we go into our sessions, once again, I would like to remind you quickly within couples of the minutes some weapons. Now, the first weapons is called the Advanced Mathematics Syllabus for Advanced Secondary Education from 5 to Form 6. This is for Tanzanian students, for our Tanzania educational system. If you're watching this program from Kenya, you're watching this program from India, from Malaysia, and from Indonesia, from Australia, from Nigeria, right? You're watching this program from United States of America, from Serbia, from United Kingdom, from Sweden, from South Korea. So make sure that you have the syllabus, the advanced mathematics syllabus of your country, right? And then check the contents, combine with what you are going to give you in Tanzania online advanced secondary school, and then you see how these programs will be helpful for you. So in case for those who are in Tanzania, so the advanced students who are in Tanzania, you can order this book in our comment sections. We are selling the original book, and also sometimes in case we get problems, we can sell you a copy of it. It's cheap, and then we can ship in any of 31 regions of Tanzania, including Tanzania mainlands and even Zanzibar Islands. Again, the second weapons we call the reference textbook, right? Or a reference textbook. This is Pure Mathematics 1, new editions, but J.K. Backhouse and his colleague. So this is Pure 1. So we have also Pure 2. And if you go into the session 00, which is General Introductions of Advanced Mathematics Form 5 and Form 6, you will see all the reference, some of the reference books that you need in learning advanced mathematics. So also, you can order this book. I will be used as a reference in coordinate geometry. You can order this book, right? It's cheap. We are providing materials. We are not actually doing business. We are providing service because we want to equip our students. Again, we have weapons number 3, question and answer, reference books of questions and answers. This is in Tanzania. We have 2 advanced mathematics papers. It means final examinations. Number 1, we call it Advanced Certificate Secondary Education Examination, Mathematics Paper 1, and the other ones we call it the Advanced Mathematics Paper 2, right? And then we'll be awarded the Advanced Certificate Secondary Education Examinations once we have passed it. So this is Advanced Mathematics 1 Review, Problems and Solutions, 2003-2018. Again, you can order this weapon, and I'm going to use that as a reference. You should have it beside of you when you're in these contents. Again, we have weapons number 4, Advanced Mathematics 2 Review, Problems and Solutions, okay, 2003. So if you're international students, you should have a questions and answers reference books for advanced mathematics. You can also order this book. It's cheap. We can ship in all the 31 regions, including Pemba and Zanzibar, right? Again, we have weapons number 5, right? The scientific calculator. We are going to use scientific calculator in learning advanced mathematics. So if you don't have any, or if you have lost it, the one that you had, or if it is fake, it's not the original one, then you have to get informed that Tanzania Online Advanced Secondary School is really providing also the original scientific calculator, which actually that you use them in advanced education and even in undergraduate education, because I know you love mathematics and it may be possible you learn or you study some of the engineering or scientific courses. So you're going to use this even in college. Okay, so you have to keep it. So you can order it. It's cheap. We have so different scientific calculators, but we prefer Casio function 991 because we are learning advanced mathematics, not basic applied mathematics. Okay, so afterwards, let me take you into the sessions. Let us go to the sessions. Right now, we have so many informations right now. So these are, we are in departments of advanced mathematics. The subject is called your team, advanced mathematics. And this is chapter 4. How many topics do we have? If you do remember, let me just do the quick review first. Quick review of what? Quick review of session 00, which is titled as General Introductions of Advanced Mathematics from 5 to from 6. So you can find it in our YouTube channel. As you go into this YouTube channel, you'll find this session 00, which is titled as what? General. So I recommend you to watch this video before any video. General introduction, right? General introduction of what? Of advanced mathematics. General introductions of advanced mathematics. General introductions of advanced mathematics. General introductions of advanced mathematics. Okay, from what? From 5, so from 6. So make sure to watch this video. We did a lot of things. And I've explained, and there I've explained to you that we have how many chapters? We have 10 chapters of in advanced mathematics, Form 5, right? Because this content is a class, in this content for the Form 5 or for the class 13, right? So again, we have another session special for coordinate geometry, which we call this session 1. And in session 1, actually we have been giving, first of all, we presented to you about the big picture of what? Of maths, of mathematics in my mind. And also, we have presented it to you against 10 chapters of advanced mathematics. Against, then we took the topic of coordinate geometry 1, okay, because it's coordinate geometry 1, right? Coordinate geometry 1, and we broke it into 3 subtopics: rectangular, rectangular Cartesians. So we call it rectangular. This is chapter 4. So you have to check also for other chapters. So rectangular Cartesian coordinate. Rectangular Cartesian coordinates. And another subtopic, we say that is called what? Ratio theorem. And the last subtopic is called the cycle. And we are going to do so many and even great things in this topic. So we have presented that, and then finally we have presented to you about concepts. Say concepts. So presented to you about concepts that you have of coordinate geometry 1. Concepts of what? Of coordinate geometry of code 1. So just to say code 1. Well, so let us go into session 2. The session 2 is stated as gradients of the straight line. And this is just like a general review, or general review of what you have been learning in previous, when we have been learning in coordinate geometry for the Form 1, and coordinate geometry are the first chapter in Form 4. So first of all, we have to make sure that we know what the meaning of of coordinate geometry first of all. So what is coordinate geometry? Before even we go further, what the meanings of the word coordinate geometry? That is the question that we have. What is coordinate? So what is coordinate or what is geometry? Let me check. What is geometry before coordinate? What is geometry? So ask yourself, what is geometry? What is geometry? In maths, of course, depends on how you define it well. What is geometry in maths? So this is the definition. Geometry in the branch is a branch. This is the one of the branch of mathematics. Okay, I want to build the foundations today of coordinate geometry 1 in your mind. This is a branch of mathematics. Concerned with the properties. So in case you find that I'm teaching you quickly, you can watch this video several times as well as you can. Properties and the properties and the relation and the relations. So properties and relations of points, points, lines, surfaces, because it can be well advanced in the learning or solving problems of coordinate geometry. But what if your kid or your son or your daughter ask you, father or mother, my mother, what is the meaning of coordinate? What is the meaning of geometry? I hate geometry since for dimension. What does it mean, the dimensional analogs? Analogs. Okay. So we write this way correctly. So geometry, before we go for the coordinate, because coordinate geometry is a combination of the two words. So myself, as your teacher, I want first of all to understand, to help you to understand what the means of the geometry. And then the next terminology we have to define what the means of coordinate. And then now we can define what the means of coordinate geometry. Right? So there are so many definitions of geometry. This is all about ingredient, right? Ingredients. So say this is the branch of mathematics concerned with what? Properties and the relations of what? Points, lines, surfaces, solids, and the higher dimensional analogies. So simply it means that in geometry, what you have to understand, in geometry, we are dealing, this is the branch of mathematics, dealing with properties. Properties of what? Properties of points. What the meanings of points? What are the properties of points? This is one. Properties of points. Also properties of 40. Properties of lines. And then properties of 40. Surfaces. For example, we learned dimensional in Form 4. Surfaces, right? And then properties of 40 solids. Then properties of 40 higher dimensional analogies. So you see higher dimensional analogies. So that's the meaning of the word geometry. So if you want to know the relationship between one point and another point, you want to know the relation between one line and another line, properties, right? Relations and what properties. So relation, properties and what relations. Between one lines and one lines. One point and a point and a line, right? Because for example, that we call the geometry, we are going to learn the distance from the shortest point to the line. So the perpendicular distance from the point to the line. So this, you see that this point, this is the point, and this is the line. So you see, one of the properties that they have is what? You find, means that if you prolong what a straight line, right? Then you find that that straight line is perpendicular. Is perpendicular to what? This straight line is perpendicular to the point. So this is the point, let's say point B. And this is line L1. So because they are perpendicular, so you can determine the shortest distance, which I will teach you. So there we are learning about the properties and relations between the point and the line. But again, we will be dealing with cycles that have been placed in XY coordinates. So these cycles are the combinations of so many points. But again, we will be dealing with calculate maybe area of the triangle, right? So triangle, it's a surface, or whether it's a solid or whatever, but it's a surface, right? So you can compute area. That's one of the property of 40 of the triangle. So we are going to do great thing in this moment, and you have to get prepared and stay focused, okay? So that you enjoy the beauty of advanced mathematics for the Form 5. Well, now let us go to the next question. You know what the next question that I want to answer? The word coordinate. Say with me, coordinate. Say with me, coordinate. Say coordinate. We learned coordinate geometry possibly in Form 1. We learned coordinate geometry possibly in Form 4 as a first topic. As a first topic. So, but we have never learned about what it is of the coordinate. But let me define for you. This is the question 2. What is coordinate? Pause the video, ask yourself, write on the piece of paper, and hence continue to watch the answer if you're right or not right. What is coordinate? Right? What is coordinate? So according to some of the references, so I found this definition. Coordinate is a set of values. A set of values that show an exact position. An exact position. So coordinate is a set of values that show an exact position. And the means of coordinate. So for example, we have longitude and latitude. So longitude and latitudes, those are the lines which give us locations or positions of a particular point on the Earth's surface. So you say the coordinate is a set of what? Of values that show exact position of an object, exact positions of something, of the surface, it depends. Right? So, and this coordinates actual is represented graphically. So you say that on the graphs, coordinate graphically, coordinate is usual a pair of points. Okay? So it's usual a pair of 14 of points, so a pair of numbers. So 2 numbers. A pair of 4 numbers. A pair of numbers. The first number shows the distance along, and the second number shows the distance up or down. So a pair of 4 of numbers. So the first number in this pair shows what? Shows the distance along. It means x-axis. The distance along. And also the second number shows the distance up or down. So up or what? Or down. The x-coordinate is called the abscissa. So abscissa. Now the first coordinate, the x-coordinate is called abscissa. The y-coordinate, just to remind you, this is called the ordinate. Remember that we also have our other online schools for ordinary secondary education for the word of God, of the kingdoms of heaven, in English and also the other ones in Swahili. So you have to make sure to visit the links we have included in this video so you can learn more. Okay? So this is X coordinates, we call them subsystem, and Y coordinates, we call them sorting coordinates. Then we have against now our 3D terminology, which you have, which the name of the topic is, what is it? Coordinate geometry. Coordinate geometry. Say coordinate geometry. Say coordinate geometry. Coordinate geometry. Say coordinate geometry. So you have the said fundamental question. Now, what are the meanings of the word coordinate geometry? What are the meanings of the word geometry? Coordinate geometry in mathematics. There are so many definitions, but I have one which is possibly the best of others. So the meaning of the word coordinate geometry is, so this we define as is a study, say study of geometry. This is the study of geometry or geometric figures. This is the study of geometric figures. This is the study of geometric figures. Geometric figures by plotting them in coordinate axis. In coordinates axis. That is. So, coordinate geometry means what? Is a study of geometric figures. We are going to learn and study geometric figures. But how are we going to start them? By plotting them in the coordinate axis. And these are only two coordinate axes. We call them X and Y. Do you enjoy advanced mathematics? Tell me in the comment sections, please. Okay. What are these figures? That are next few questions that I know it's clicking your mind. Which figures can we study by plotting them on the coordinate axis? These figures are a straight line. So let me just list them. These figures are, first of all, we are going to learn about straight line as figures. Secondly, we are going to learn about curves. Then thirdly, figures, we are going to learn about cycles. Okay. Then afterwards, we are going to learn about parabolas. Then we are going to learn about hyperbola, how we can plotting them on the coordinate axis, hyperbola. Then we are going to learn about polygons, parabola, ellipse, first of all, ellipse. Then we are going to learn about polygons, say polygons, etc., etc., etc. Mention how many figures? 7 figures. So in coordinate geometry 1, we are going to learn how we can present straight lines in the coordinate axis. Also, we are going to learn how we can present cycles in the coordinate axis. a little bit about curves, polygons. And the polygons is triangle, and even at the, we call them rectangular figures, right? Rectangular figures, maybe parallelogram, programs, four-sided figures, four-sided polygons. But in coordinate geometry 2, we'll teach you how we can plot parabolas and parabolas and the ellipse. Stay connected. So that is the first chapter or first topic in Advanced Mathematics in Form 6. But also it's the first topic in the ordinary diploma, basically engineering and scientific mathematics. So, those are the key points that I wanted you to know. Now, let us go to the title of the session 2. What is the title of session 2? Gradients of the straight line. But I have again the second definitions of geometry. Geometry can be defined as the science of the properties of lines, angles, surfaces, and solids, and relations between them. So here, I still have some geometric figures. Okay, so this is not kind of geometric figures, but you have also angles. So you can add number 8 angles. So we learn some about angles on the coordinate axis, right? So let us learn these concepts of gradients of the straight lines, and these sessions will be just a quick review of what we have done during our Form 4 education. So let me speak in terms of letters or formulas. Consider figure 2 below. So this figure 2, it has two axes. X-axis, which is horizontal along, this is abscissa, and also y-axis, and here we have original, 0,0. So simply write O. Suppose that we have a certain straight line, right? Certain straight line. And these straight lines, we have to think about how we can find its gradient. But the good thing that these straight lines, it has what? It has two known points. This is x1, y1. And the second point is here. This is b, x2, y2. Okay. So then, in this case, okay, so we have that. So in this case, you find that you have changing. So here on this side, we are going to have changing y, and also horizontally, we're going to have changing x. Right? So when you speak about gradient, say gradient, just to remind you, because I know you've been staying for a long time at home without reviewing the concept of gradient, possibly forgot. Don't want to assume. So slope, we use the letter M. Simply define that is changing y or changing x. So slope, which is gradient for that case, we say that for that case, we say that will be y2 minus y1, which is equal to x2 minus x1. This is what you remember in your form for education. But you want also to add up something in your mind. You can also take y1 minus y2 over x1 minus x2. Right? Okay. So this is a two-dimensional plane, not three-dimensional as in vector. Okay. So that is the first point that you have to remember. But again, we are very interested to know about the equation AQN. It means that equations. Questions of the straight line. Of the straight line. So equation of the straight line. So you want to know what the general equations of the straight line. That's all about Form 4. And in case you forgot, you can go in our other schools that called TANZANIA, online ordinary secondary schools, and square bracket Olenjolai. And our YouTube channels for all levels called the TANZANIA all level secondary school, in square bracket Olenjolai, right? So you have to go there to get so many information. So in case you want to find out the equations of these straight lines, possibly a certain straight line. So how do we do that? So you say that we have, suppose the slope of this line is known. So we have to take another arbitrary point, which is this we call the coordinates of C, which are x, comma, 1. So slope, we say that this is what? It will be y minus y1, possibly. So you formulate a triangle here. So this is the rectangle triangle, so you can use Pythagoras theorem. So y minus y1 and x minus x1. So to formulate the equation of the straight line, we introduce 1, then cross multiplication, so that the gradient x minus x1, this is equal to y minus y1. So y is equal to m x minus what? x1. Right? But x1 plus what? Plus y1. So the general equations of the straight line is this. Y is equal to gradient changing x plus y1. Generally, these equations in geometry, if you do remember, we just write this one. Y is equal to m x plus c. So this is the general equation of the straight line. But again, that in order to master this topic, you still have to remember the concept of x-intercept and the concept of y-intercept. Okay? Make sure to go through. How can you find the x-intercept of two variables? Okay. So this is the equation of 40 of the straight line. Equation of the straight line. Okay? But again, want to think about something very important. We enjoy the beauty of chapter 4, that's called in chapter 2:1. Consider the right angle triangle. In this right angle triangle, it is B, D, F. Excuse me. So let us consider right angle triangle. B, D, A. B, D, A. When you consider it, so you have to redraw it. Consider the triangle. Let us draw the way it is. This is an angle. This is an angle that we have. But we can make this also a full line. Just for the matter of applying what? Pythagoras theorem. Okay? So if we have this triangle, and if we do remember that, That is B. This is A. This is B. That is T. Right? So if this is the case, we have changing Y. Here we have changing X. Right? Changing Y, changing X. So this will be tangent of theta, opposite of our hypotenuse. So changing theta over changing X. This is equal to, but I should not just call it tangent. This, you say that, let me call it right now slope. Slope or gradient, right? So this is gradient. Gradient is equal to changing x, y over changing what? Over changing x. At the gradient. But also from what? From 3D concept, if I want to find tangent of angle theta, this is opposite of adjacent. Right? So what is tan? So you say, okay, so we say that suppose that is question 1. Very interesting. So we say that tan of angle theta here is equal to opposite of adjacent. So this is the opposite, which is changing y, because I've written here the formula of adjacent, which is changing x. So this is equation 2. So if that's the case, you can take equation 1 and you put to equation 2. Right? So we say that m, which is gradient, is equal to slope. So m means, or remember m is equal to slope. So if you equate these two equations, simply just to finish up here. If you get those two equations, equation 1 and 2, then we find that the gradient or slope is equal to tangent of angle theta. Tangent is equal to what? No, tangent theta is equal to what? Gradient. Or gradient is equal to what? Tangent of angle theta. So gradient or slope is equal to tangent of angle theta. Okay, so before you end these sessions, let me quickly discuss about, present to you, ladies and gentlemen, about properties and relations of the lines. And I will have 2 lines only in this session. I don't know if I will manage to teach you all of them. Okay? The first 2 lines we call them parallel lines. Say parallel lines. So, ladies and gentlemen, our beloved school and private candidates who are watching these programs anywhere in the world, we say that we do have parallel lines only. We have discussed about we have only parallel lines. What is the meaning of parallel lines? Or what are the parallel lines? That's the first question. What are the parallel lines? What are the parallel lines? So parallel lines, these you call them are the straight lines. Not curve are the straight lines that are straight lines in which if they extend from 0 to positive or negative infinity. If you extend from maybe from 0 to positive or negative infinity. Right? So the straight lines in which if they extend from 0 to positive or negative infinity, which they extend from 0 to positive or negative infinity, in which that we say, which we never meet, which will never meet, right? Even if they extend to infinity, they never meet. That means of 40 parallel lines. They will never meet. So you won't have any balance that in this way, no. Okay. So let me sketch these parallels. So this is the x-axis. This is y-axis. X-axis, y-axis. X-axis, y-axis. Suppose that we have two parallel lines here. And just to see how we can present them geometrically. So these are the sample of the parallels. If you examine these parallel lines, each line has made an angle theta 1. Okay? So we have that the gradient for the first line 1, gradient for the second line. First line, the gradient for the second line. So we say that according to the geometry, according to it. Okay, so we say that because these are the parallel lines, tangent of theta 1, this is equal to tangent of theta 2. So gradients of the first line is equal to gradients of the second line. Okay, that's the formula for what dealing with parallel lines. So remember that this is called as parallel lines. radius 40 for the parallel lines. Okay, we've been enjoying solving so many questions. Don't worry about that. Okay, so I have given you a quick review about parallel lines. You know some other lines that we need, which we are familiar with, perpendicular lines. Also, this is the content for Form 4. But I'm not sure that how we've been taught. Perpendicular, say perpendicular, say perpendicular. Okay, excuse me. So perpendicular lines, or orthogonal lines, or lines which intersect at the right angles. So you can say perpendicular lines or orthogonal lines. So what are these perpendicular lines, first of all? What are perpendicular lines? Say perpendicular lines. About to finish this section. What are perpendicular lines? So we say the perpendicular lines are the straight lines which meet at the right angle. That is, perpendicular lines, these are the straight lines which meet at perpendicular angle or at right angle. So make that language. Are the lines as the lines which meet these are the lines which meet at the right angle. Okay. So say are the lines which meet at the right angle. Okay, so then let us say that we have our XY plane, which is two-dimensional. Sketch also yours. And then suppose that we have two lines that intersect. So this is the first line. Okay, that's the first line. Then here, suppose that you have another line. Okay, so this is the one of perpendicular line, and this is the second line, and here this is also perpendicular line. This is perpendicular right angle. It's the right angle, and this is the right angle. And then suppose here the first line made an angle theta 1. When we rotate, anti-clockwise. And this is 90 degrees. Also suppose also LO2 make an angle of theta 2. Okay? Make an angle of theta 2 at this place. This is A, this is B, this is C. So you have theta 1, you have B, so it means you have A, B, C. That's the name of the triangle. Okay, so if you consider right angle triangle A, B, C, this is the straight line. Remember that we are learning about gradients, straight line. So I want to teach about gradients of perpendicular lines. I've taught you the general gradients, the question of the straight line, and second, and also I taught you about parallel lines, and I taught the gradients of the parallel lines. And right now I'm teaching about gradients of 40 perpendicular lines. So remember that the slope of 40 of perpendicular lines. Because why am I reviewing this concept? Because we are going to use these concepts of perpendicular lines, and we are going to use the parallel lines in the word problem, for example, of the problems of coordinate geometry 1. So consider right angle triangle ABC. So consider right angle triangle ABC. So if we consider now, we have a right angle triangle of this shape. So this is the right angle, and this is point B, this is point A, this is point C. But again, we have an angle here, theta 1. We don't know the angle of this side, of this, yes, of this side, of this side of this part. But we know that this is the straight line. This is the x-axis, which is x-axis, and this is y-axis. So we know that what the total degrees or the total angle of the straight line is 108. So to get the angle here, we say that this one is what? Theta 2. So we know that the total degree from here, means from here to here, is 180. So to get the angle inside of this triangle on this side C, we have to take 180 degree minus theta 2. Right? So that is, so this is the first step. So we say that consider. So here we said consider. We say that consider. This is figure 2, 2. So this is figure 2, 2. So this is the second step. Second step. Because we are deriving the gradients of 40 of perpendicular lines. So the third step now. Third step, we say that the total of angles of 40 of any triangle is 180. Right? So we say that, so if you find the total angles of that rectangle triangle, you have theta 1, then you have 90 degree, then you have this angle, which is 180 degree minus theta 2. The sum of all these angles should be 180 according to the principles that you have in coordinate geometry. Well, so if we add this, we have theta 1 plus 270 degrees, and then this is theta 2, then you have 180. Right? So you have theta 1 minus theta 2. Can bring this angle on this side. So you have 180 minus 270 degree. Right? So if we do these simple basic operations or subtractions, so here we get negative 90 degree. Okay? So if you have negative 90 degree, then we can, what do you have to do? We have to divide by negative 1 and divide by negative 1 on both sides. So right now we have theta 2, because this becoming negative and this becoming positive, minus theta 1, this is equal to what? 90 degrees. Because I know that many students, they just know or they have been taught in Form 4 just that if two lines are perpendicular, then the products of the ear gradient, of the ear gradients, or of the ear slopes is equal to negative 1. So suppose that this is equation 1. This is okay, this is question 2. And here it was equation 1. So you have just to simplify. And then we go for the first step. The first step of these derivations of gradient of perpendicular lines, we say that now apply the tangent. It means that apply tan to both sides of 40 of equation 2. Right? So what is question 2? Let us recall. This theta 2 minus theta 1 is equal to 90. So you're applying tangent on the both sides. So tan of theta 2 minus theta 1, this is equal to tangent of 90 degrees. Right? So by using a scientific calculator or by using concepts of the special angle that we learned in Form 2, we know that tangent of 90 is what 1, because tangent of 90 is equal to sine of 90 over cosine of 40 of 90. So sine of 90 is equal to what? Tan of 90. Tan of 90 is equal to, what is equal to 1? No, it's not equal to 1, ladies. It's not equal to 1. Okay. Okay, so the next is say that, let us say that, okay, fine. So let us consider tan of 90. Tan of 90 is it infinite? If you use your scientific calculator, no, this is common. Tan of 90 is undefined. Why it's undefined? Because this is equal to sine of 90 over cosine of 90. So if that's the case, we say fine. So we say the tangent of 90, this is equal to sine of 90 is what? 1, while cosine of 90 is what? 0. So suppose that this is equation 2, equation 3, equation 4. This was equation 3. Okay? So you can substitute equation 4 into equation 3. So for that case, you say tangent of theta 2 minus theta 1, this is equal to what? 1 over 0, which is undefined. So suppose that this is equation 5. So you go for the what? For the fifth step. The fifth step, we say that recall compound angle. Call compound angle of 40 of tangent. Tangent when you are subtracting two angles. Okay? You enjoyed the beauty of advanced mathematics? Please tell me in the comment sections below. Tell me that you enjoyed this content from which school, also from which country, from which city, from which continent. Okay? So we say that from concepts of what? Concepts of compound angle, tangent of theta 2 minus theta 1, this is equal to what? This is equal to tangent of theta 1 minus tangent of theta 2 divided by 1 plus tangent of theta 1 and then times tangent of theta 2. So simply we say that tangent of theta 1 minus tangent of theta 2 divided by 1 plus tangent of theta 1 times tangent of theta 2. This is equal to 1 over 0. Right? So if that's the case, what do you say? You say, well, So now we have to simplify. How do we simplify? We have to cross multiplication. Right? You see? You have to cross multiplications. If you cross multiplications, we have 1 plus tangent of theta 1 times tangent of theta 2, and then we say this is equal to 0 times what? Tangent of theta 1 minus tangent of theta 2. So 0 times tangent of this would be 0. So this is 1 plus tangent of theta 1 tangent of theta 2, and then this is equal to what? 0. Right? So make tangent of theta 1 and theta 2 the subject. Okay? So that is, okay, to make this one the subject. So to make the subject is tangent of theta 1 times tangent of theta 2. This is equal to negative 1. And this will make your equation what? Equation 6. We just know the formula, but possibly you have never learned how to derive it. So we say that also the 6th step, you have to recall. Recall that I've already told you by using the right angle triangle that presented on the xy plane that the tangent of angle theta, right? This is equal to the gradient, or is equal to the slope of the line, right? So if that the case now, we say that if this is the case, the tangent of theta 1, this is equal to what? Gradient of the first line. Tangent of the angle made between the second line with the x-axis. This we call it M2. So if that the case now, okay, so we say that M2. So if it is M2, suppose that this is question 6 and this is question 7. So you got the last step, 7th step. We say that substitute equation 4 and also equation 7 in equation 7, equation 8. So equation 7 and equation 8 in equation 6. So substitute this. So you have slope 1 times slope 2. This is equal to negative 1. So this is what will be in the right. So you say that the slope of perpendicular lines, say perpendicular lines. So you have to remember this formula. Perpendicular lines is given because we are going to use even in a cycle when we have the conditions for the two lines to be perpendicular, for the line to be a tangent, for the straight lines to be a tangent to the cycle. So it's given as what? Gradient of the first line times gradients of the second line. This is equal to negative 1. So very important formula for coordinate geometry 1. So keep it. So let me do one example and then I leave the homework for you. So you have to enjoy. In case you have any question, don't hesitate to ask in the comment section below. Right? Okay. So we have a question here. This is example 1. This is example 1. The question says the two lines are given as 1, 2x plus 8 minus 3y. is equal to 0. And the other line is x plus k, y plus 5. This is equal to 0. Find the value of k. Find the value of k. That will make lines to be A parallel, B perpendicular, parallel, B perpendicular. Okay, that's it. So you said two lines are given as 2x plus 8 minus 3y is equal to 0, and x plus ky plus 5 is equal to 0. Find the value of k that will make lines to be what? A parallel, B perpendicular. Is it a simple question? You can pause the video and try yourself, and then you continue watching the solution that I'm going to solve for you. Do you enjoy the beauty of advanced mathematics? Tell me in the comment sections, please. Don't keep quiet, please. I want to hear from you, my wonderful student. Solution. So we'll be given two equations, okay? Two lines, two straight lines. These are straight lines, these are straight lines. But the coefficient of y is not given for one line. So we have to find the value of k, which will make these two lines to be parallel. This is parallel lines. Okay, this is parallel lines. They never meet. Or perpendicular lines. So they meet at right angles. So these are perpendicular lines, right? So one demonstrate. These are perpendicular lines. These are perpendicular hands. These are perpendicular hands. These are parallel hands. Parallel hands. Parallel hands. Parallel hands. Parallel hands. The distance between them is constant, even if I extend my hands to infinity. And these are perpendicular hands, right? So these are perpendicular hands. They make 90 degree, 90 degree, 90 degree, 90 degree. Okay, solution. So let us, so you see the question testing our understanding now of what we'll be dealing. However, we'll be dealing with gradients, but we'll see how we use those previous concepts to solve this problem. So let us go into the business. Two lines. So a big US two lines. The first one is 2x plus what? 8 minus 3y. This is equal to what? 0. So, and the second one, so we give us as x plus ky then plus 5 is equal to 0. So the first fundamental state, we say that express. So let us call this is equation 1 and this is equation 2. Express equation 1 and 2, right? Express equation 1 and 2, okay, in form of y is equal to mx plus c. So c, y-intercept, m gradient, x-intercept. Okay, c is y-intercept, m is gradient. This is very important, even in practical physics, in practical chemistry, on drawing the graphs, even in practical electronics, practical electrical. Very important equation. So to express equation 1, the big is 2x plus what? 2x plus the y-intercept is 8, and 3y is equal to 0. So let us make y the subject. To make y the subject, we have to alternate. We can have 2x on this side, and then we bring 3y on this side. We divide by 3, we divide by 3. This we just do quickly. 2 over 3 x then plus 48 over 3. So this is now our new equation 3 because we've changed its form, right? And then we have to take the next equations, okay? y. Okay, so the second equation is x plus ky then plus 5. So we have to make y the subject. So to make right the subject, on this side you have ky, and then you have negative x minus 5, then divide by k, on this side you have divide by k. So this one will make us negative 1 over k, x, then minus what? 5 over k. So simply find that y is equal to negative 1 over k, which is gradient t, and then x, and minus 5 over k, which is y-intercept. So suppose that this is equation 4. So you have to find the value of k, which make two lines to be what? A parallel. So now we are ready for the second step. Do you enjoy the beauty of advanced mathematics? So the second step, we say that, okay, compare equation 3 and the 4 with what? The standard equations of the line, which is mxc. So it means for equation 3, the gradients which was correspond, this the simplified equations of equation 1 means the gradients of the line here. The gradients of the line here is 230. Then gradients of the second line, M2, for this case it is negative 1 over k. So then we go for Roman A, second step. So the second step, we say that for parallel lines presented on xy planes, we say that the product, gradient 1 is equal to gradient 2. So you have to recall, right? So what the gradients of the first line is 230. What's the gradient of the second line? It is negative 1 over k. So we have to cross multiplication. So if you cross multiplications, we'll find that twice k is equal to negative 3. So over 2 over 2. So the value of k, which will make the two lines to be parallel, is negative 3 over 5. It's negative 3 over 2 over 5. Are the gradients of the two lines. So the value of k, so we say that the answer for Roman A, say therefore, the value of k that makes two lines parallel is negative 3 over 5 out of 5. Then let us go to part B of the question. This will be the fourth step. So in case you want to offer your freewheeling sense-giving in order to support the running cost for this program, don't hesitate yourself to use the telephone number 0759745331. In case you want to do the bank transaction, read the descriptions to see the more banky details. So he said that again for perpendicular lines, right? For perpendicular lines, we say that gradient 1 times gradient 2 is equal to negative 1. And what is gradient 1? Gradients of the first line is 230. Gradient of the second line is negative 1 over k. This is equal to negative 1. Right? Okay. So if this is the case, if you multiply, we have negative 2 over 3 and then k. Right? If just to do multiplications. This is equal to negative 1. If you divide by negative 230 and here negative 230, so you'll find that the value of k, which will make the two lines to be perpendicular, this will be positive, and this becomes the numerator is 3 over 2 but positive. 3 over 2 but positive. 3 over 2 or 2/3? Because if it will be positive, then 3 over 2. 3 over 2 now. Cost is 2, 3 over k. We try to divide this one. 1 over 2. Answer is 1 over 1 times 3 over 2. Yeah, so I wonder that. How did they get this? So select k. Okay, so let me do this calculation. So for this case, you say it is negative 2 over 3k. This is negative 1. So 2 3k is equal to 1. Okay? So if we cross multiplication here, we get this is 2, this is 3k over 3 over 3. I wanted just to make a mistake. So the value of k had to make the two lines to be perpendicular is 2/3. Is 2/3. And even here I made a mistake, excuse me. Negative 3 over 2. And here also it is negative 3 over 2. Let me check in my, yes, negative 3 over 2. Here the value of k is 2/3. So therefore we say that the value of k makes two lines perpendicular is 2/3 at the response. So let me give you the homework and then end this session because I know that you are so much exhausted. Yes, you are so much exhausted, so that you join me in session 3 of College Metro 1. So this is example 2, and this is homework 2 because these questions in session 2, and state like this one. Say given, the big given two equations, a1x plus b1y, this is equal to plus c1, this is equal to 0. And also another equation is a2x plus b2y plus c2. This is equal to 0. And the questions ask me that show that the two lines are perpendicular. Those two lines are perpendicular. Are only perpendicular if we find this line, a1, a2 plus b1, b2, this is equal to 0. So make sure that you do that homework question. It's very simple. You'll be given two equations of the straight line, but this is a little bit concept. It's a little bit concept, okay? So given that a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0, show that the two lines are perpendicular if a1 times a2 plus b1 times b2 is equal to 0. Try that question, do it, submit your solutions in the comment sections, and hence enjoy the beauty of advanced mathematics. And this is the end of session 2, which was titled as Gradients of the Straight Line. I invite you to join me in session 3, when now I'm going to teach you another concept of the coordinate geometry 1. I thank God who have given me a gift of teaching. I thank God who is receiving always my sacrifice or my offering, including this one that I'm offering to Him, so the present and future generations of the Tanzania, as national students and even international students. I thank God also who was with me during the preparations of these sessions and even at this time when I've been teaching. And I thank God who have given me a chance that to join me and learn this material of coordinate geometry 1 today. So I'm really praying for you always, for all my online students and even my digital students. I call them digital generations students, right? And also pray for me so that we have to accomplish this assignment we have been given, and in order for you to enjoy the beauty of advanced mathematics. Remember to subscribe, share this content, read descriptions, send your free will Thanksgiving through this telephone number, concentrate on the material, do the homework, use the reference books, buy the books, buy the scientific calculator, keep on focusing, think differently, how you can take these classroom instructions and how you can solve your real life problems in your community. So I thank God once again, and may God bless you abundantly, and I would like to meet you in the next session. May God bless you.